All right, we're going to pick up the second half of section 7.4. There's two last examples, so if you want to try these on your own and then come back and see how you did on them, that might not be a bad idea. We're going to go ahead and work these out. So this time they're giving a sine. So sine, you know, is opposite over hypotenuse. Between 0 and pi over 2, this is going to give us quadrant 1. So we're going to be drawing our triangle in quadrant 1. Again, theta has to be connected to the origin. So whenever you're stuck and you're like, I don't know where, it can't be here. This is definitely a 90 degrees. But in order to know it's not this angle up here, it has to touch the origin. And then we have opposite. So from theta, opposite is 24. Hypotenuse is 25. And so this is the side we're missing here. So we will go ahead and do a squared plus b squared equals c squared. Numbers are a little bigger, but just use your calculator. So across here, this is your hypotenuse. So I'm going to do 24 squared plus b squared equals 25 squared. Let's see, 24 squared, 576, plus b squared equals 625. Subtract 576 to both sides. You get 49. Whoops, that's supposed to be a b. So b can be 7 or negative 7. So again, if it's this distance here, which is going to the right on x, we know it's not negative direction, it's positive. So this is going to give us a 7. And now we can find cosine and tangent. So these are the two we're trying to work out this time. So cosine of theta, cosine is adjacent, so 7 over hypotenuse, so 7 over 25. Tangent of theta is opposite, so 24 over adjacent, so 24 over 7. And again, you do not make those mixed numbers, you just leave them. That's about it. Not too bad. I do expect to see you drawing these triangles on homework, so please make sure you're drawing the triangles. All right, last one. This one, they gave us a little uglier number. We have a radical. Same process though, exactly the same thing we did before. So here is going to be your opposite. Here's your hypotenuse. Between pi and 3 pi over 2, that's going to be quadrant 3. We're going to find cosine and tangent. So if we draw our triangle in quadrant 3, something like that. Theta has to be connected to the origin. That means this is my right angle. I want opposite, so opposite is over here. Now again, the negative can go to the top or the bottom, so as you're figuring this out, generally they don't make hypotenuses negative because it's a length. So this distance here can't be a negative number because of the fact that it's a length. Okay, so the hypotenuse will never be negative. It will only be either the horizontal movement or the vertical movement. So this negative is actually going to go in the top, and that should make sense because we're going left on the x. So this is going to be negative, whoops, we're going to go negative 2 rad 3. Let me fix that. So it's negative because it is going down. So it's not going left, it's going down. And then hypotenuse, which is the side across, is a 4. And so we are going to figure out what this side is. And again, it should be negative because we're going left. So we're going to have negative 2 rad 3 squared. Please put parentheses and square the entire thing. Plus b squared equals 4 squared. When you square this, you're going to do negative 2 times negative 2, which is 4. And rad 3 times rad 3 is just 3. So I'm going to come back to that one, and then 4 times 4 is 16. So then 4 times 3 is 12. And now I can subtract 12 to both sides. B squared is going to give me 4, so B is 2 and negative 2, but we already said it's going left, so we know it's negative. So this will be a negative 2 here. Then we're going to go ahead and find cosine and tangent. So cosine of theta is adjacent, so negative 2. Over hypotenuse, which is 4. And you would want to reduce this to a negative 1/2. Tangent, opposite over adjacent, so opposite negative 2 rad 3 over adjacent, which is negative 2. So please don't forget that when you have the same numbers outside, you can cancel them off. So these two -2's will cancel, and I'll be left with just a radical 3. So there's my answers for those. And then this problem does ask if the identity holds, so we're going to go ahead and work that out below. The identity is not involved tangent. There is other identities that involve tangent, but we're just doing sine squared plus cosine squared. So we're going to do sine squared theta plus cosine squared theta equal to 1. So we're doing this part right here. So sine squared, or sine, is -2 rad 3 over 4. So -2 rad 3 over 4. And we're going to square that. Plus cosine, we got -1/2 squared, and we're hoping to see if we get a 1. Again, just like before, you want to square everything exactly the same way. So do -2 and -2, that's 4. Rad 3 and rad 3 is 3. 4 times 4 is 16. You could have reduced this to made it a 1/2, same difference. And then I can clean this up further because 4 and 16 will cancel. So I end up getting 3/4 when I'm done. 1/2 and 1/2 is going to be a 1/4, and negative will be positive. And 3/4 and 1/4, does that equal 1? It sure does. So yes, the identity holds. All right, if you have any questions, feel free to message me on Edsby. Good luck.